really got me thinking once I saw this APL machine is the control is running the whole thing, the machine and the automation. So Haas designed it, Haas built it, it's all integrated and it all works. There's no interfacing, so the fact that it's all built into one is really the only way that I think it will work and work well. My name is Andrew Starrenburg. The company is Micro-Cut Engineering. Our product line is impact wrenches, and they are primarily used in industrial applications. An impact wrench is really comprised of two halves. The back half, the handle of the tool, has an air motor in it. The front half is where all the impacting is going on. That mechanism is being driven by an air motor, and that is what's delivering the blow to the fastener to either loosen it or tighten it. The impact mechanism is made from very special alloy material, and those components are being machined on regular VF2s or APL machine like you see right behind us. We started out making what we call the hammer for the hammer mechanism of this tool, turn the blanks, and we were loading them up on a small manual pallet changer. We started originally in a Kurt vise, one by one, then switched to a manual pallet changer, and then as the volume kept increasing, we've moved now to simple, effective automation for getting the parts in and out of the machine in an unattended fashion. So what we're doing is we're using high-speed machining, a VF2SS. We're using through-the-spindle coolant, high-pressure coolant for drilling. We're using through-the-spindle air blast to clean the part. And all these operations are all tied together, and then parts are loaded in and out automatically, and we go on to the next part, essentially. So we're trying to get an 8-hour run. We're manned during the day, and we're trying to get it set up to where we can just walk away at the end of the day and let the machine run at night. It's really a standard VF2SS. There's really nothing different about it other than it has an APL on it. So once the machine was installed by our local HFO, the machine was up and running within an hour or two, and we actually made a run that night. Now that's a part that we'd been running previously on a VF2SS. We had it all figured out, but we weren't sure if we were going to get a full night running out of it, and we did. On our first night, we thought, well, let's just go for it. Why not? The only thing we were concerned about was chips. How are we going to handle the chips? Now, I did order this machine with dual augers in it because we knew that that would be an issue if you're trying to run unattended. You really need to think about chip handling. The fact that Haas is addressing the automation by using simple templates or VQC templates is really brilliant, because obviously lots of Haas users are using the VQC templates for probing, and it makes it very, very easy to create powerful probing routines. But when you couple that with automation and addressing the automation with just a VQC template, it becomes really, really ultra simple. We're trying to use the Haas machines to do everything that we could possibly need to have done on our parts. We have one machine over here that's running spline milling. We turn it, then we put it into a VF2SS with an indexer, and we're doing single spline cutting, where we're roughing and finishing and producing a finished part right off the machine. I just think that more automation, completely integrated into the control of the machine, where there's a single source of responsibility for the machine and the automation all at one, I think that's really where it's at, and I think that's where we can make money consistently over the years, and I think that's kind of where we're headed.